That way you can follow along as I'm going to show you something if you have questions. So if you got them handy, maybe but if you don't need them, you can always close them later. Let's see who shows up here in the next minute. I'll give everybody another minute. There should be 21 of us. We got 9. Kind of a gray Monday morning. So we're going to talk about 3 things today. I'll review something, make a revision on something that we talked about last week using the slides. If you got them handy, you can just make your notes right on them if you wish. We will talk about the homework that you submitted that has been returned and graded. Maybe one person is not, now that I see your name in the list. I'll do that as soon as we're done. And then the third item on our agenda today is to show you what we're going to do this week, what your homework will be, or what your week's work will be, or however you want to describe it. Okay, so 14 of us, that's usually about it. That's our standard participation, even though there's more of you in the class. So again, as you're walking in, welcome to another Monday, week 7. Can you believe it? We're almost halfway through the semester. Feels longer, feels shorter. Okay. Any immediate questions before we start off? So we're gonna review your homework. I'll show you some more pictures or examples of what some of your peers did, just so you can follow along and see what's going on with other people. Since we can't talk to each other or have face-to-face, I'll make a few revisions based on what I saw in the homework, and then I'll tell you what we're going to do this week. All right, well, welcome to Monday. Woohoo! Today is Canadian Thanksgiving, so happy Canadian Thanksgiving. Those of you who are Canadian. If you're not, you can still participate too. Yes? Fair enough. All right. So let me get my slides. Standard error. So these are the slides that we talked about last week. Okay. I have made a few revisions on them. I've even added a slide. You do not have to reprint them. They are already uploaded. Of course, you're welcome to download them. The file name says revised on it, so it's obvious that it's different than what you had before. If you want your own copy, you know where to find them. If you don't, you can just make the adjustments on your current copy, however you work. Okay, the reason I'm bringing this up is because multiple people did different things on your homework. Some of you, and we went in 2 different directions. That's the easiest way to say it. And both of them were correct, but there are subtle differences between the 2. So I felt like, all right, I need to restate this because I only mentioned one particular approach. Okay. Everyone can still hear me? Thank you. Okay, so here we are. We have a scatter plot. And so remember that your scatter plot is just that. It's the data points that you graph against 2 variables, right? One on the x-axis and one on the y-axis. And the reason that you add a trend line is that you cannot connect the dots. There is no relationship between any 2 dots on that graph. Shell number 72 is not related to shell number 47. You cannot connect a dot between shell 47 and shell 48 and shell 49 because those numbers are just arbitrary, right? You could take the same number of shells and shuffle them up, give them different numbers, and you would still get the same graph. So you cannot connect the dots. So in a scatter plot where you are investigating the relationship between 2 variables, in this case width and length, you can draw a trend line. Now, Excel calls it a trend line. Statisticians call it something else, which we're not going to go into. They call it a regression line, if you've heard that word before, a regression line. Okay? So I'll call it a trend line because we're using Excel, and that's what Excel calls it. It doesn't matter because the trend line is the line of best fit. between all those points. And you can see how that line is drawn, that it more or less runs through the cloud of data points, right? And so there's very little space between the data point and the line. And that's what it means by the line of best fit. You're minimizing the distance of each data point from the line. And of course, this line has to be a straight line. This is a linear relationship. Okay, so there can't be any bends in the line. Okay, now you can't really, we could calculate the equation of that line, but you don't really use it to predict data points. Okay, it's just there to summarize the relationship. So I don't think that part is really new. All right, next slide indicates, we had this slide before, I can determine the strength of the relationship between those two variables. Now remember that coefficient R fluctuates between -1 and 1. -1 is a very strong relationship. It is just a negative relationship. 1 is a very strong relationship. It is just a positive relationship. Okay? That just tells you the direction of the line, whether it's going in this particular pattern, which is a positive relationship, or perpendicular to this and running has a negative slope. Okay? Now, Excel calculates two different numbers. One is called R and one is called R squared. There is a difference. I was asking you to play with R squared, and some of you calculated R squared into R. So this is why we're having a discussion. R squared, okay, tells you about what percentage of the variation in the Y variable, in this case length, is explained by variation in the X variable, in this case width. Okay, so that statement that I made in your homework, right? What percentage of the variation in shell length is explained by the variation in shell width? That's R squared. In this case, about 98%. That means that there's very little unaccounted for variation, right? So the closer that R squared gets to 1, more and more variation is accounted for in the estimate of Y. Does that make sense so far? I'll wait for a comment. Okay, so R squared is kind of that fill in the blank. It tells you the percentage of the variation that is explained in the Y-axis variable by the variation in the X-axis variable. Okay. Now, R, on the other hand, measures the strength of the relationship. So R fluctuates between -1 and 1. You saw this graph before. I've just added more doohickeys on it. Okay. So R is typically called the correlation coefficient. Okay. Again, R can have a positive slope, in which case it is a positive linear relationship, such as these two examples at the top, the red. Or it could have a negative slope. The trend line can have a negative slope, in which case it is a negative relationship. It is indicated here in the blue. And all that means is, if you read the graph here in the positive relationship, as X gets bigger, Y gets bigger. That's what the positive relationship means. The negative relationship is just the reverse. As X gets bigger, Y gets smaller. Okay, that's it. And then, of course, you can have a line that has a slope of 0, a horizontal line, in which case there's no linear relationship. Now, this is R. So R tells you how strong the relationship is. The closer it is to 1 or -1, the stronger the relationship. 0 is no relationship. Okay? So a value that says R equals 0.5 is as strong as the value that says R equals -0.5. The only difference is the direction of the slope of the trend line. Okay? Otherwise, the value is the same. Okay. When we calculate, what's on this slide? Okay, so this is what we're talking about as R squared. So R squared is a measure of fit of the data points to the trend line. Okay, as R squared increases, our prediction of Y increases or becomes more accurate because less variation is unexplained. Okay, so that's the fill in the blank equation. Now, here's the trick. When you use Excel, Excel will calculate for you the R squared. If you use the trend line, it will calculate the R squared value for you. Okay, and that's all I was asking you to report in your homework, which is fine, because this was the sentence that I used. How much variation in shell length is explained by variation in shell width? And it was 98%. And some of you calculated R. So you can use Excel to calculate R. You just take the square root of R squared, and you got 0.94, right? And some of you reported 0.94, but there is a difference between R squared and R. If we come back to this slide, some of you even figured out the equation to calculate R without using the square root of R squared. And in Excel, the formula is equal sign always tells you a calculation is coming. The prefix is correl for correlation. And then you highlight variable 1. So you highlight the column of shell length, and you highlight the column of shell width. And it doesn't matter if you use shell length first or shell length second, because the correlation is going to be the same. Okay? So just pausing here. And I'm mentioning that because since people talked about R and some people did R squared, there is a difference between the two. This is how you interpret the difference. R is a measure of strength of relationship between the two variables. R squared is an indication of how well the data points fit to the trend line. Okay, so you can calculate R squared using Excel and then calculate the square root. Or if you get fancy, you can put in the equation equals correl variable 1, variable 2. It doesn't matter. People did both. I could tell from the way they did their graphs. Okay. Questions on the distinction between R and R squared? Yes, no? I'll wait for a few people to comment before we move on. All right. So let's get rid of that. I have to stop sharing. And now, if you would like to see some of your peers' homework, I'll just show you some things that what some of your colleagues have done. I think it's interesting. Some of you will get ideas from it or see how things can be done. Again, it's just variation on a theme. You weren't graded. You were only graded on how well you did, not how well everyone else did. So here's the scatter plot. Here's just two different versions of the scatter plot. Some of it comes down to personal taste, as you see. We've got blue dots and blue dots. We have a continuous trend line. We have a dash trend line. Our axes are well labeled. That is great. Our scale looks pretty good. If you get picky and you don't like that, okay, so maybe here's where you write some of this down. Okay, if you get picky and you don't like one as compared to everything else which has a decimal place, you can highlight that. I can double click it. Now, if you work in the same, if your file is on the same computer, then you don't have to go back to the Excel file. I can actually make those edits over here in PowerPoint. And because I downloaded your homework, I have it's connected right back to the PowerPoint. I can go to Axis. All right. If I go down here to number, let's get rid of this. If I go down here to number, see general, and I can pick number. And now it lets me specify the decimal places. If I change it to 1, then now I've got the 1.0. Okay. So if you like symmetry, maybe that's what you do. Okay. Now you'll notice that this person calculated R. That's correct. It was 0.94 in this case, so very close to 1, right? That's all very strong relationship between water depth and water velocity. If you forgot, again, you can click the line. Here comes my trend line information. I can click display R squared on the chart, and there's my R squared. You don't have to go back to your Excel file. I can't see that, so I jacked it up, and I have 88%. Okay? And there you go. So there's the difference between the R squared and the R. And you see they're different values, which makes sense since R squared is R squared, right? Okay. There's your scatter plot. I asked you to redo a histogram. They were much better done this time. Congratulations. This is what they look like. Some of you pointed out that wing length, the way that I told you, was actually the millimeters times 10. So if you want to know the real wing length, you would have to divide that by 10. You can't have a 38 millimeter wing. That would be almost a 4 centimeter wing in a housefly, which could be a big fly. Okay, so that's all it meant. Okay, in other words, instead of giving you a bunch of decimal places, I just multiplied everything by 10. But there you go. Looks great. The bins have to be in order numerically from small to large or large to small. Doesn't matter. You can't rearrange them, and all the bars have to be touching. Don't like those white lines, you can get rid of them. But who cares at this point? Okay. Here's the bins that you made where you had to figure out how many bins to use, and you had to define your bin width. And so this just varied depending on how many bins you selected. So there's just variation on a theme. I think this is 7 bins. This one is 10 bins, and this one is 11 bins. Are they all correct? They're all correct. Except bristles. We'll get rid of the O. Okay? So, but this is an interesting, I think, something for you to think about. If you looked at all 3 of those graphs, would you say they're different? They plot different things, or they tell a different story? I mean, I think I would look at them and think like, wow, that's 3 different data sets. And then if you look closely, I look and I notice, no, they're not 3 different data sets. The bin size just is different. Well, depending on the bin size, you get a different story, right? This one says that, oh, this is almost a normal distribution, slow up, quick drop. This one would suggest, I wonder if this is bimodal distribution. There's a group here, and then there's a group here, but there's very few in the middle. But when I add a bin, now I get this distribution, which even looks a little more normal than this. So depending on the number of bins may affect what the message is that someone may take away from your graph. But all 3 are correct. And so again, the idea was just you get to pick the number of bins as long as the bin width is identical. Okay? The bin width has to be identical. It would make no sense to have a central bin here that was 46 to 54 and everything else is 2. Does that make sense? Because that means you're counting too many links in this particular bar. All right, but again, this was well done overall. So you're getting better. Congratulate yourself. You're getting better at making the scatter plots. You're getting better at making the histograms. And then we got into some fun. Okay, so I asked you to graph these bacterial counts, which were based on colony counts, into a bar graph. And most of that was straightforward. I think most of you built a bar graph. The only extra step was putting on the error bars. And just here's 3 different versions of how you might have done it and what they'd look like. Okay, all 3 of these were correct. All right, the biggest mistake in this, well, I'll show you later, but this was the ideal format of what you get. You had 4 different sources of bacteria: the pen, the cell phone, the doorknob, and the toilet handle. So you see some people put sources and the 4, some people didn't put the sources, they just put the 4. It's up to you, right? It is important that you put a density scale in there. So the mean of densities, that's even better because these were the means of 10 different numbers. The only thing I would add here is cells per milliliter, right? That's important how you're measuring the density. So this is what we have, okay? If I click on this, I come over to the sidebar, vertical error bars, both directions. There's a cap on it, custom. which means that this person had to select the standard errors that they calculated in their Excel file. You couldn't click this one. Watch what happens when you click this. All the error bars are the same length. That is incorrect. The error bar is the error of that mean. This error bar is the error of that mean. Okay, now it's not going to let me go back because I have to actually highlight the original data. Okay. All right, moving on to show you another one. What's it going to do? Is this going to crash on me? If it does, I'll meet you back online. Not sure what's happening. All right, as we wait for this thing to do whatever it's doing, are there any?
You are currently the only person in this conference.
All right, sorry about that. Can you hear me? Yep. All right, I don't know what happens. So I got 2 more slides to show you. So here's the last figure that you made. And here's just, again, variation on a theme, okay? So here's what I asked you to do in this upper left-hand corner. Make sure you can see that. Here's what I asked you to do in the upper left-hand corner. Weeks is on the x-axis, and the means for each week are on the y-axis, okay? All you had to do is each dot represents the mean, and each bar represents the error, the standard error of that mean, not the confidence interval. Some of you plotted the confidence intervals, whatever. You weren't asked to do that, but I figured if you could do that, you could plot the standard error. So just pay attention. These were just the standard errors of the means. In fact, you didn't have to calculate the confidence intervals for this table at all. Okay, but if you did, great. If you didn't, whatever. The only difference was you added the trend line. Okay, in this case, you did not add a linear trend line, you added an exponential trend line. And the whole point is just to show you that you can have different trend lines. Okay, so if you add a exponential trend line, you can't calculate r squared, and you can't calculate r because those are for linear relationships. Okay, so again, these are means. The trend line is the line of best fit of those means. And so here, when you come to this example in the bottom left-hand corner, you can't add the trend line and connect the means. Okay, or at least we're not going to. So just keep in mind, if you add the trend line, or if you're asked to add a trend line to a scatter plot or anything, then what I'm saying to you is I don't want you to connect the individual data points. Okay? Because that trend line is the line of best fit. And here someone just converted the dots into bars. Now the only thing I'd say here is, right, this should be a histogram, but this is a continuous time, but that's why you don't add the bars. But I mean, whatever, variation on a theme, right? So this is what the last figure could have looked like. It had to be the plot of the means. Here's the most common error on those two figures, those last two figures. And I don't know whose is whose, it doesn't really matter. But this was common. I'd probably say at least half the class did this. Okay. You're plotting, in this case, you're plotting the 10 colony counts and you're dividing them up by the location. So you got 4 bars, one color for each location. We'll just call that toilet seat, whatever that one is, cell phone, pen, and you're plotting it for each of the 10 colonies. And the same thing happened down here. Here, this is a plot of the 12 different plants per week. And so each line represents a different plant. Okay, and so this is why this standard error looks so weird with all these things, because there's 12 standard errors on there. Okay, which is a lot of work to do, right? That's a lot. I went and clicked on them, yeah, you're right. That you selected the correct standard errors, but you don't need 12. Okay, so the goal of these last two figures was to graph the mean of your data points, not the individual data points. So what is graphed here is the individual data points and the individual data points from the 12 plants for each of the 6 weeks. Okay, so why do we do that? Why are we plotting? I was gonna say plant the mean. Why aren't we plotting the mean, right, and not the individual data points? Because remember, the mean is going to summarize those individual data points. It is very hard to pick out the pattern here or here if we don't have the means. Now, is it appropriate to graph like this? If that's the message you want to send, if the point of the graph is to show you the different growth trajectories for 12 different plants, then that would be the correct graph. In this particular instance, you're asked to summarize the growth rates by week. Okay, so you're going to summarize them by week for the 12 plants. And therefore, that gives you a mean of those 12 plants and the standard error for that mean for those 12 plants. Okay, so this was the most common error in this homework, was not plotting the means. Okay, so I pause. Are there questions? Your homework was returned to you. There should be comments posted through the assignment link if you have not seen them. If I don't comment on a particular figure, I didn't have a comment. Okay? So the 17 of you that are here, have you seen your comments? Do you go back and look for your comments? Have you been able to find your comments? I guess we should start there. Okay. Yes, yes, and yes. All right. Thank you, Jess. Because they're, I hope they're useful. The comments aren't supposed to be like super picky. Well, I need to change that color. I don't care about the color, right? I care about the overall message, right? And so that's what we're working on. Any comments that you would like to make about that homework that you submitted on whatever it was, Friday, Saturday? I can't remember. Today's Monday. I'm assuming it was a little more straightforward because the improvement that I saw in your scatter plots and histograms. Is this fun? Is this entertaining? Is this annoying? Anyone wish to comment? You don't have to. Just asking if you wish to comment. Try to get rid of this. Yeah, all right. Yeah, that's okay. I prefer reading graphs over reading assignments, Victoria. We're not going to write any lab reports if you put your E's at rest. We may write short little stuff here and there, but we're not going to write any lab reports. We build up to those skills. Again, why is Dr. Borden spending a lot of time talking about graphing when this is, a biology lab? Trust me when I tell you, the skills that you learn in putting these things together and using them, you'll be able to use them in every course. But more importantly, you're going to use them a lot in biology, and the skills, the basic skills you have related to interpreting these stats is going to go a long way. Okay? Particularly if you take 182 and 182L next semester, they're going to pick up assuming that you know some of this. Okay? All right. So is there anything I can show you or you would like to see with Excel? I noticed in some of the comments, some of you are funny. You write comments and you write stories to be inside your file, which is fine. And some of you are pointing out that it's like, yes, there are 2,975 videos, YouTube videos about how to do stuff with Excel. And I do appreciate you using the discussion board to kind of hash out some of those questions and resolutions. It makes it a lot easier. And I think it, puts some of you at ease that it's like, no, you're not doing anything wrong necessarily. Multiple people have the same problem. Okay? So don't get too upset if something doesn't work. There's a solution out there. Okay, do you know what that, in plotting it, McKenna, or calculating it? I can pull up an Excel file and wait till she replies. After we do this, I'm going to give you some homework for this week and then turn you loose, okay? And it won't be graphing. Woohoo! We'll take a break. Okay. Let me kind of see if I share my screen again without doing too many things fancy. All right. Double check that you can see this. Okay, so this was your homework, right? Now, here's one more comment, and I'm going to make this suggestion, and the suggestion is more of a suggestion. This is more of a, here's how I want you to do it, okay? So write this down and take notes if you need to. I want you to use Excel to do your calculations. It's obvious that many of you were doing your calculations, I don't know, on a calculator or somewhere else, because then you were just inputting the answers in here. And when you did that and it was incorrect, I cannot tell where the error was made. Okay? I can't tell. So for example, many of you said, we calculate the square root of 12 and just wrote the answer in, but I can't tell how you did it. And so when you went to calculate the standard errors, they were incorrect. And so I have no idea how the formula was done. So let me just show you real quick. If this is old hat, go get yourself a T. So we're going to calculate the mean. I want the mean of these 12 values. I can go to auto sum. I'll click average, and it's already done it for me by calculating J10, which is there. So there's the equation for the cell, J10, J21, right? There's the cell address. So if I click here, 21, 23, but 22 and 23 are just, they're empty. But if you want, I can change it to a 1 and it won't matter. It should be the same number. I'm going to drag and drop it across. Done. Okay. Is it? No, it keeps changing on me. 10 to 21. Oh, why? I don't want some. That's why you have to use common sense. For example, so this might have happened. Is it possible that you can have a mean of 855 when the maximum value is 87 or 92, right? No. Sometimes you got to step back and look at this and see, this just should even make sense, right? And then you know there's an error in your equation, okay? So there's the mean, standard deviation. Okay, now I'm lazy. I don't like using the buttons over here, and I already know what the equation is. So equal sign has to precede all calculations. I'll just train you to do that. STDEV is the standard deviation. I'm going to calculate the range. I will close the bracket and hit enter. and then drag and drop. Okay. I need to know the number of counts. I have 12 counts, right? I'm going to need to know the square root of n. N is sample size. Folks, sample size, remember, is an exact number. Can you have a decimal? Absolutely not. So if you write n and there's a decimal in your sample size, that a warning light should go off and say something is wrong because I cannot have 6.5 sharks. Okay? I can't have 12.35 plants. So the square root of n is equal to SQRT. And I can't put 12. All right, I could put 12. They're all 12. And that would be okay. But if I had different sample sizes in each week, then I would have to go do that by hand every time. It's easier to just, well, it doesn't matter. I'll put 12. Okay. And of course, if they're equal sample sizes, that number has to be the same all the way across. It sounds stupid, but that's an easy check to make sure if there's an error. So standard error, what's my equation? Is equal to standard deviation divided by the square root of n is equal to this. Drag and drop. Now, I know my rules. Everyone see this logo right here under number? This is how you change the number of decimal places. All right? And there we go. All right, McKenna. So here are the standard errors. Here are the means that I want to plot. Okay? The standard errors will be on the means. I will take this. I will put that there. That's just easier for me to do this way. I will click this. I can go to Insert. And there I am. Okay, so there are my means by week. You with me? All right. Now, how do I add the standard errors? It should be that I can click here, over here to add chart elements, error bars. I can pick standard error, and I know that's incorrect because all the error bars are the same. Now I got this cross pattern, right? So I'm going to click the horizontal one and hit delete, and now I just have the vertical ones. If I click a vertical one and double click, I get, here's my format error bars. I will click custom. Now I have to tell it what to plot. I will specify the value. You notice how there's a positive and a negative? The positive is the error bar above the point, and the negative is the error bar below the point. So I can do this. I have to highlight the standard errors. Now, can I end there? I can end there. Watch what happens. I only get the error bar above the point, right? Whatever. I can go back and add it below. If you don't like that. So I can just go here. I can add this. I'll hit OK. And now I should have it above and below. Okay? It's just really small. But it's there. And that's how you plot the standard error of the means, right? Each standard error is different, and it corresponds with this mean. This one corresponds with this mean. Okay? I can add the trend line, click. There's multiple ways you can do this. Chart design, add element, add trend line, linear, incorrect. You can just tell by looking at it. Trend line, exponential, better. Click linear, delete, we're good. There you go. Okay? So first of all, you have to, calculate the standard error of the means. Then you have to plot the means. Then you can add the standard error to the plotted mean. Okay? I can calculate it, putting them on the graph is not working. All right, did you take notes of what we just did? Click, 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 click. Okay, so the only way to do this and get this right is just do it over and over and over again. So if you bungled one of those two graphs where you had to add the standard error bars, you listening? If you bungled one of those two graphs where you had to add the standard error bars and you didn't do it, or you plotted the individual data points and not the means, you can take your file back, you can take my comments, and you can redo one of those two graphs. You can't redo them both, or you can redo them both for your own understanding, but you can redo one of the two graphs and resubmit it to me. Okay? So if that's you, here are your instructions for doing that. You listening? You're going to take the homework file that you submitted to me. You're going to duplicate it. You're going to make a copy of it. If you're a Mac person, you're going to hit the Command key plus D, and that will duplicate it. If you're not a Mac person, I forgot what it is. Maybe it's Control C will copy and Control V will paste. You're then going to delete all the sheets except the graph that you're going to repair. So back over here, I don't want this. I did that one correctly. I'm going to go up here, Edit, Sheet, and I can delete the sheet. Because when I open up the graph, your file, I only want to see the new graph. Okay? So just keep the one sheet that you're going to do. And then when you submit it to me, you submit your Excel file that has one sheet, not a bunch of sheets at the bottom. So you're going to click on the sheet, Edit, Sheet, Delete. Just keep the one you're going to revise. You can revise either this one or this one of the two in order to practice. Of course, you can always redo them all. The more times you do it, the more comfortable you will feel. Okay? I'm looking for any questions or comments. Someone's typing, so I'll give them a chance. So that homework is not listed in that. I just make that offer to you now. If that's you, you can redo one of those two things. Either the bar graph, standard error, or the trend line with standard error. Okay. Any other questions or comments? Again, there's nothing wrong with redoing them both, if that's you. There's nothing wrong with getting the practice. Okay, I'm going to show you one more thing today, and then we will move on. I'm going to share my screen. We're changing tact. No more graphs for a bit. Give you a bit of a breather. And let's see. Sorry. I got to open all this crap before I can even share it. All right. So now we're moving to this thing called SimBio, which is a free software application that we're going to do some experiments in. Some of you, let's see, there's 21 of us, minus 14. 14 of you have already started this and done the first assignment back in September when the announcement came out. 7 of you have not. Okay? I can tell you who you are if you're interested. But you're going to follow the directions and you're going to go to the SimBio page. It's been posted twice now. One was just, I think, last week or the weekend. You're going to go to the SimBio page. You're going to register to get this software called SimBio. So the publisher is called SimBio. Okay? Free copy. You have to register. You have to use your SVSU address, email address, and something else. and then you get into the program. And it's going to ask you to download the software. And you're going to download the software. And the software is called SimUtext. Okay? The SimBio is the company. You're going to go to that page. You're going to download it after you put in your credentials. You're going to download this thing called SimUtext. Okay, this is what it's going to look like. Then you're going to log into it using your name and password. See if I remember. Okay, and there are three experiments that we're going to do. I don't remember. This is student view. So there are 3 experiments that you're going to do. One of them, and 14 of you have already done this, is the understanding experimental design. There are 3 sections. So when you click on it, this is what it looks like. It takes you through pages. It has ideas. You're going to answer these questions. You get credit for answering these questions. I would urge you to take some notes on this because it complements and supplements our discussion on the experimental design and uses some new vocabulary. Okay? And you're going to keep going. Da, 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 da. As you see, there's 16 little pages of this. Each page is not that big. But again, take some notes as you go through this. And then you're going to come to section 2. In section 2, you're going to start doing more things. Okay, so now you're going to start looking at these graphs. Now that we've talked about graphs, maybe you got a little better appreciation for what it is you're looking at. All right, and again, you're going to be answering these questions as you go along about how to develop a hypothesis. Again, this is just reinforcement and practicing. This is how you get better. And at the end of it, there are some graded questions. There are 10 graded questions. Okay, you will not see the answers for these, but there are 10 graded questions, and you will earn credit for doing this lab and answering the questions. Now, if you go through there and you blast through it and you do poorly on the interactive questions and you just get a 0 on all the graded questions, then that's going to reflect in your score for this unit. So take it seriously and take the graded questions seriously. Think of the graded questions as a quiz. Okay? So for 14 of you who have already done that, congratulations. Your only homework this week is to work on Darwinian snails. If you haven't registered and haven't done this, you get to do the understanding experimental design and the Darwinian snails. Okay? So here's the Darwinian snails lab. Again, there are multiple sections. You get to make a graph this time. You read the number here. You kind of click it over there. You're going to make a histogram. Okay? And then you're going to go through a number of simulations, and you get to play games as if you are a crab, and you just kind of follow the directions. Okay? And then you're gonna watch these crabs eat these various snails under different conditions of natural selection. And then you have these questions to go along with this. Okay? And so this is what you're going to do. As you go through this, there's a little function here called Notepad. It's going to open. You can add things to your Notepad. You might have to add a note. No, you can add a note or delete a note. There's the page. I can add a page. I can rename the page. And then I can add something on this page. And what you're going to end up doing is adding the, no, it's not going to let me. What you're going to end up doing is you can add the graphs that you make into your Notepad. And then when you come to answer the questions, you'll have this bigger piece that you can work on. Okay? And so that's what you're going to work on. So this one it's a little longer. There are 5 sections, and then there's graded questions at the end. Okay? And that's what we're going to work on this week. And then we'll come back. I'll review this next weekend. We'll come back to it, and we'll probably do something with this again next week. But the first thing, when is it due? I don't know. Let's do. I'm looking at your thing. I told, let's see. Numbers, not there, not there. I don't see it right offhand. I think it's due Friday. It's either due Friday or Saturday. Both of them are due Friday or Saturday. Is that right? It's got to be. How come I can't? Oh, I know why it's not in the assignments. So this software does not link to Canvas, so I've got to do it all by hand. So just a second, and I will tell you when is due what. So understanding experimental design. I'd like you to have it done by 10/17. So what is the 17th? 17th is a Saturday by 8 p.m. Okay. Friday by 8 p.m. Darwinian snails. Let's see. Can you do both of them by Friday at 8 p.m.? Yes, it does say the 25th. I initially wrote down the 25th for the snail one. That's like 2 weeks. You think you can do them both by the 17th? A bunch of people are typing, so I give a chance for this to show up. Yeah, I think what I say on Saturday. Saturday's the 17th, right? Can you get them both done by Saturday at 8 p.m.? Nah, you can hand in the graph as soon as possible, but by Friday or Saturday. Can you get all that done? Okay. So if we can get it done by Saturday at 8 p.m., that's great. For those of you who haven't done it, we're going to sign off here shortly. I want you to spend the 2 hours registering, downloading the software, and within that 2 hours, you can get that experimental design done. You can do it in less than that, actually, a lot less than that. So in the next 2 hours, you can get all your software done, you can get experimental design done, and you can make that one graph, and you're going to email it back. Let's see. I will make a new assignment that just says upload just for that one question. Okay? I will send you, tell you what, I will send you an announcement after class. I'll make a new assignment for the one graph, and I will put the due date as Saturday at 8 p.m. for those 2 SimBio exercises. Is that clear? Okay. So we'll see how this goes. You can tell me what you like about it. Again, take some notes as you go along. Nothing's going to hurt by taking your own notes. And then we'll just proceed from there and see what's left. All right. So I'm done unless you have other questions and comments. Miss Owen still here? Yes, Miss Owen is still here. So you heard that. That's what we're doing, Jessica. See a bunch of people typing. We'll see what comes up. If you're good, spend your 2 hours and get your Darwinian snails done. And you got the week to yourself. Good luck with the dog. And happy Canadian Thanksgiving. Everyone go have a turkey sandwich today.